Okay, so for this skill, we had to find A and B, and they both had to be greater than 10. So I chose 15 and 15, and they had to create a special right triangle, and mine created a 45, 45, 90 triangle. So the first thing we had to do was plug it in to z equals a minus bi. So z for us is going to be 15 minus 15i. So from that, we can figure out that our r value in this equation that we're going to put in is just, or a parenthesis there, is 15 root 2. We know this because it's a special right triangle, and you can use the unit circle for that. And so this 315 will be our angle because 45 is our reference angle. Since this is a 45, 45, 90 triangle, so 315 will be our theta. And so we know that this equation, z to the nth equals r to the nth times CIS, which is just cosine plus I sine, of theta n, theta times n. So what we get when we do that is 15 root 2 to the power of 7 because of r to the nth. We're looking for z to the 7th in this problem, so that's why we have the 7 up here. That's not a subtraction sign. I was just underlining it, but I'll circle it. Okay, so it's 15 root 2 to the 7th times CIS, which is just cosine plus I sine, 315 times 7. When we multiply these out and then split up cosine and I sine, this is what we get. Cosine of 2205 plus I sine of 2205. We can change the 2205 to 45 degrees because these are just coterminal angles, and we can subtract all. We can subtract all that away to get just 45 because they're just coterminal angles, so we're allowed to do that. After we subtract the 2160 from it and get 45, we can find out that cosine of 45 and I sine of 45 are both root 2 over 2. So we're left with root 2 over 2 plus I root 2 over 2. When we simplify this and do 15 root 2 to the power of 7, we get approximately 1.9 times 10 to the 9th, which is that right there. And then root 2 over 2 plus I root 2 over 2. So when we FOIL that out, this is what we get. We get 1343502 8,884.3 plus the same thing, 1343502 884.3, but with the I. That's what we get for our z to the 7th power. For part B, we're told to find the fifth roots of z. And that basically means it's z to the power of 1/5. So we can use a similar process, but instead of n being 7, it's going to be 1/5, as you can see here. And since we are looking for the fifth root, there will be 5 answers, each equally distant from each other. And since 360 divided by 5 is 72, each of these will be 72 degrees away from each other. So for the first answer, we do the same thing we did last time. Z to the 1/5 is equal to 15 root 2 to the 1/5 times CIS 315 times 1/5. So when we multiply these two together, and then split them up, we get cosine of 63 plus I sine of 63. And then when we just do cosine 63 and I sine 63, we get 0.45 and 0.89. When we do 15 root 2 to the 1/5, we get 1.84. Then we multiply these two together and these two together, we get 0.83 plus 1.64i. So each of these are 72 degrees from each other. So the next angles that we'll calculate are 63, 135, 207, 279, and 351. And that will give us our 5 different answers. So for the second answer, we do the same thing, z to the 1/5 equals 1.84 times, except it's multiplied by cosine 135 and plus I sine 135. When we do the same steps, we get z of 1/5. The second answer to be negative 1.3 plus 1.3i. For the third answer, we do the same exact thing, but with 207 degrees, and we get negative 1.63 plus, we subtract. It's plus negative 0.84i, but so that just means it's minus 0.84i. For this one, it is z to the 1/5. For the fourth answer, we do the same thing, but with 279 degrees. When we multiply all that out, we get 0.29 minus 1.82i. For the final answer, we do the same thing, except with 351 degrees. And then when we multiply these out, we get 1.81 minus 0.29i.